Good morning, ladies and gentlemen. Today we're going to talk about cross multiplication. Um, Students can use cross multiplication to reduce your fractions. It only happens when you're multiplying fractions, but when we look at it, division is truly multiplication because you change the division sign to multiplication and you use the reciprocal of the second fraction. So really, in half our math, we can be doing cross multiplication to reduce our answers. Now, why would you use cross multiplication? Many of the mistakes I've seen the last little bit have always come in the reducing part. You can't find the factors quick enough, the numbers get too big, and then you have to use those numbers, especially when we're doing order of operations. You had to multiply something first, then you had to use this really large denominator and find a new denominator when you're adding a fraction. So if we cross multiply, it keeps everything small and easier to use. Once you get the hang of it, I know you will do it all the time because it is an easy shortcut once you get the hang of it. But anyhow, for the steps, you're down here. First, you look for a common factor in any numerator and denominator. You look for 1 on the top, and you look for 1 on the bottom. And it doesn't matter if they're right over top of each other. Sometimes you have 2 fractions you're multiplying, and then when stuff we'll do, we'll even use it with 3 fractions we're multiplying. And you divide each number by the common factor. You're going to repeat this as many times as possible until you run out of common factors in a numerator and a denominator. And I'll show you what we mean right here. So if we were going to use this fraction or these set of fractions, 3/7 times 21 over 6, we look for a numerator and a denominator that has a common factor. So if I was just to start with a 3 and the 7, I would say, okay, 3 and 7 are not common factors. 3 goes into itself, but it definitely won't go into 7. But if I stick with that 3 and I use the other denominator, the 6, I should be aware that 3 goes into 6 twice. So to keep our work neat, we neatly cross out the 3 and say to yourself, 3 goes into 3 one time, and we write the new number down. And 3 goes into 6 twice, so we cross out the 6 and write a 2. And now we have 1/7 times 21 over 2, and we're getting better, but there are still other numerators and denominators to look at. So if I look at 7 and 21, I know that that's a common factor, and if you're weaker with your math skills, you should be using the back of any notebook that we have, and you look at the first factor, and then you just go along the line and see if the other factor, if the other number shows up. But anyhow, I know that 7 will go into itself once, and 7 will go into 21 3 times. And now my fractions are 1 over 1 times 3 over 2, and there are no more common factors. So that is simply 3 over 2. Had we not done this, if we had not reduced and simply multiplied as it was, we would have had 63 over 42. And then when you try to reduce, it would have been much harder for you to find a common factor for both of those numbers, and you would have to do it 2 or 3 times. And this is the way that you, this here, cross reducing, cross canceling, is going to help you a lot. And we're going to do lots of practice with it. Okay, so here's our next example. We have 15, 6, 36, and 55. And there's actually quite a few ways you can do this. And it really doesn't matter if you're cross canceling one way and your desk partner is cross canceling uses a different numerator and denominator. You will always end up at the same number regardless. So there's no wrong way to do it. Anyhow, when I look at this question, some people might they look at the 15 and the 6 first, 15 over 6, but my eyes are immediately drawn to the 6 and 36 because I know that's one of my favorite ones. 6 times 6 is 36. So I'm going to use that one. 6 goes into itself once. 6 goes into 36 6 times. Now I'm looking at 15 and 55, and I can see they both have 5s in them, so that's going to be my next plan of attack. So 5 goes into 15 3 times, and 5 goes into 55 11 times. Now, unfortunately, there's no more we can do because we have 3 over 1 times 6 over 11, and we can't go side to side. We always have to pick a numerator and a denominator. So in this case, our lowest terms is going to be 3 times 6, which is 18, over 11. Of course, that'll reduce to 1 and 7 11ths. You know you did it right is when you change it back to an improper, or sorry, not an improper fraction, a mixed fraction, there is no more reducing to do, and it's completely done. Okay, so now I've written one that has 3 fractions in it, and it could happen. Now we do order of operations, and we normally break it up. We do the first set of fractions first, and then multiply the second answer. But when we are multiplying a set of fractions, it's just like if the question was 2 times 3 times 2. If we were doing those in our books way back in September, most of you probably wouldn't have done it in 2 steps. You would have said 2 times 3 is 6, times 2 is 12. And you would have done it all in the same line of your on your notebook. You do it as one step. And it's similar to this. If we're just multiplying fractions, you can do them all. But first, these numbers are way too big, and we're going to have to start reducing them. So I know for people that have weaker math skills and you don't see your common factors right out, this will be a little bit of a challenge, and many of you will probably prefer to do the question and try to reduce it at the end. But remember, you never get better at anything unless you put the time and effort into it. This is the way to go. If you're going to be going academic math, there's a lot of factoring out of numbers and of exponents, and it's exactly this sort of stuff you have to do. So this is a skill you might as well pick up early than try to pick up later. Anyhow, so now we got to look for common factors. I can see they're all even. So 2 will go into all of these. But remember when we were dividing out before, you want to take your biggest factor, otherwise you're doing this forever. So I'm going to try to take big numbers to do the top and bottoms by. So if I'm looking at this first one, I'm going to try to start with 8, because I know 8 will go into a bunch of these numbers. 8 goes into itself once, and 8 goes into 16 2 times. So that's my first start. And again, I can use all of them as long as I take a numerator and a denominator. I'm going to move all the way down to the end now, and I see this 30 over 20, and I see 10 goes into both of them. So I'll take 10 goes into 22 times, and 10 goes into 30 3 times. Still lots of numbers that we can deal with. What will I do next? How about 3 and 24? I know 3 goes into itself once, and I know 3 goes into 24 8 times. Still pretty neat. If you're noticing, I'm not scribbling my way through it. I'm just neatly going from one to another. I have some 2's. What can I use here? I can use 4. So 4 will go into 8 twice, and 4 will go into 36 9 times. Still working away. 9 over 1 times 2 over 2 times 1 over 2. The only thing I can get rid of is a2 from the top and a2 from the bottom. So 2 goes into itself once, 2 goes into itself once. So I wouldn't normally rewrite the question. I would just multiply 9 times 1 times 1. And 9 times 1 times 1 is 9. And here I would multiply 1 times 2 times 1. And that would be equal to 2. You have to change that improper into a mix. 2 goes into 9 4 times with 1 remainder, and the denominator stays the same. That is a big challenge for people that are new, and we won't start here. We'll start with just 2 fractions at a time, and tomorrow the grade 8s for sure will move up into 3 fractions, and they'll start with probably a mixed fraction that they have to change to an improper and then do cross canceling. But today we're just going to simply put and stay with the 2 fraction cross canceling. I'll give you one last one so that you feel good about going into today's work. All right, when you first look at this question, you're saying, hold on, Mr. Ross, that's a division question. You're telling me we're doing this multiplication. Truly, it is a division question, but we all know what happens to all of our division questions. 45 over 8 divided by 15/16. The only way to do that is to change the division sign to multiplication and invert the second fraction. So that would be 15 or 16 over 15. Once we have it this way, we can start cross canceling out because it's a multiplication question. I know that 15 and 45 are factors of each other, so 15 goes into itself once, and 15 will go into 45 3 times. Just as I know 8 and 16 are factors, 8 goes into itself once, 8 goes into 16 twice. What this is 3 times 2 is 6 over 1, which equals 6 as a whole number. Now, just so you understand why we're doing this, I think when you get to this step right here, if we hadn't cross-reduced and we had used 45 times 16, that would have equaled 720. And 15 times 8 would have been 120. maybe it wouldn't have been so bad with this one. You could have started with at least 20 and reduced. Probably even use 60 if you understand that, or divide them up. But the numbers are much larger when we don't reduce.